Hi, Mr. Murrat. How are you?
Hello.
Hi, Mr. Elmir. Elmir, can you hear me?
Yes.
Good. All right. Murat Elmir, good to see you again. Okay. Now we are in the last week. Today we have 1 hour, and on Friday we have 1 more hour, and that's it. And next week you're going to have exam. And last time actually we started this S1, and we did I think like 12 or 13 questions, and the rest we will see. Also, I want to see this S2 together with you. And on Friday maybe we will discuss the last 10 questions in S1 and S2. And after all questions are similar, okay, we will go a bit fast today. We will see. Okay, Elmir, are you ready?
Yes.
All right. So, Elmir, also next week on Tuesday, I think your exam. Did you get any message from the what is it? That's tuition center, education center, whatever. I don't know. It's about the dates and do you have your ID number and everything, or not yet?
I think so.
What do you mean? You think so?
I'm not sure what they sent us.
I mean, who knows your parents?
Yes.
Uh, okay. Because I heard it will be next Tuesday and at their venue, right? Not at your school. So you should not be late. And anyway, Elmin, also on Sasmo Day, you will have exactly the similar questions like this, okay? On the first page, you need to write your name and maybe school name, and you will have ID number. And the second page, and there are rules and regulations. These are general rules. And after that, 2, 3 blank page for calculation, and after that, question 1 and 2, the first 15 questions, and they are from, it's just advancing from the easiest one to the hardest one, especially the last 5 questions are harder one. Anyway, also about the exam, we will talk on Friday. Now let's have a look at these questions and practice uh, as many questions as possible. So here in the first one, evaluate, right? Very good. With that calculator, how do we do that? If you multiply first these two things, right, that's equal to 1,000. And here this one is 20. So here we have 20 times 1,000, which is equal to 20,000. That is B. Elmir, read the question.
The digits of a two-digit number are switched. The resulting number is 75% more than the original number. Which of the following is the possible value of the original number?
Okay, which of the following is a possible value of the original number, right? Of course, if the choices are not given, we can evaluate this, but here since it is given, so immediately you should just use these numbers, right? That is the fastest way in multiple choice questions. So this one is 21, right? And plus 75% means 3 over 4 times 21. And as I say here, it's not a whole number, so it cannot be the answer. 28 plus 3 over 4 times 28, that is 28 plus, and the 7, it is 21. That's equal to 49. And the 94 is not, right? 24 plus 3 times 4 times 3 over 4 times, what is it? 24. That's equal to 618, so that is 42. So now if you just switch this, 24, 42, 42 is 175% of 24. So the answer is C. How we solve this? Given that x is less than 0, simplify the expression. What is it? What is the correct answer? Yes, Elmer, why is it taking so long?
It will be very x minus 8x.
Which one? A, B, C, D, E?
Oh, yeah, minus x
Yeah, because X is negative, right?
plus
So this
8.
one, it is minus X. And this one negative because 4 does not belong to negative 1, it is minus. And cube root of 64, it is 4. Cube root of x cubed, that is x. So what is it? E, right?
Yes.
Good. Murat, are you here? Okay. All right, Elmer, let's do this question. Find the next fraction in the sequence below. A quite easy question. What is it? Elmer, any answer?
No.
Why not? As you see here, all these fractions are in their simplest forms, right? So here 1 over 2. And how about this one? See here, 1. If I get, I'm just hoping that maybe numerators follow some rule. Here, if you multiply by 2, it is 2 over 4. And this 5, okay, 5 over 8. And 7, 5 over 7. If you multiply by 2, it is 10 over 14. 10 over 14. And it is, okay, 5 over 8, 10 over 14, 17 over 22. And if you multiply by 2, 26 over 32, right? So what are these? It is plus 2, plus 4, plus 6, plus 8, plus 10. Ah, there's a pattern here. How about the
So it's
denominators?
37 over 44.
So denominator is plus 1 and plus 3 plus 5 and plus 7. This should be plus 9. So next one is plus 11. So there's 37 and the plus 12, 44. Is it? D?
Yes.
Good. That is D. Because usually, if they give in the simplest form and you have to just write, just change them into some different equivalent fractions and try to find any pattern. That's the way to solve this kind of questions. Anyway, Elmer, read the question.
The least common multiple of two positive integers is 384. If the ratio of the two positive integers is 3 to 8, find their highest common factor.
Okay. You have 2 minutes, Elmer. Yes, Elmir, no answer.
Is it 24?
Is it what?
C.
C? Really? Why?
Hello.
Hi, Ayan. Highest common factor. Find the highest common factor of these numbers. It is okay. Okay. Did you say C?
Yes.
If it is C, what is the first number then? I mean, if it is 24, the highest common factor, what are those numbers? Anyway, let's just do this because we know that's the highest common factor. If let's say we are talking about two numbers and the ratio is 3 to 8, that means that A, let's say, is equal to 3x and B is equal to 8x, right? So the least common multiple of these numbers, A, B, that's equal to 384. The question is, we need to find the highest common factor, right? So least common multiple means that we know that that is divisible by this number and also that is divisible by this number, right? So see here, 3 and 8, 3 and 8, it is 16. All right, 16 times A, x squared. Just a minute. Just a minute. 3x. Okay, 8x. So the common factor, two numbers, is 24. So if it's 24. Okay. So because the 3 and 8, they are relatively prime numbers. If you divide 384 by 24, that's equal to, what is it? Is it 16? 240 and 384.
Yes, it's 16.
Okay. So that's 16, right? So if it is 16, 384, 16. Okay, it is 16. So 4, A is equal to 12. B is equal to, because 16 and that's x squared, that's equal to 4, it should be 32. If it is 12 and 32, the highest common factor is 4. Isn't that correct? Because if these numbers are 12 and 32, right? And what is the least common multiple of 12 and 32? It is 384. And how about the highest common factor of these numbers? It is 4. And these numbers in the ratio is 3 to 8. So it is none of the above, I think. 24 cannot be the answer. What do you think, Almir?
How did you get 12 and 32?
If it is 16, 24. Okay, sometimes. Anyway, here, all right, A is equal to 3 times X, B equals 8 times X, right? And 3 and 8, so they are relatively prime numbers. And A times B. So if it is A
It
times B,
isn't. It isn't
huh?
4 because LCM of 32 and 12 is not
Ye-
384. It's 90. No, it's
yes,
120 something.
I think, yeah, I noticed that. Maybe here, for every number, we have to use least common multiple of two numbers, A and B, and highest common factor of these two numbers, that's always equal to the product of these two numbers, that is A times B. Now from here, it's given that's equal to 384. And here I'm looking for this, let's say that's equal to, what is it, H. And this A and B, that's equal to, what is it, 24x squared. So from here, if you divide 16 times H, it must be equal to x squared. So if you factorize this, I mean, take the square root, x should be equal to 4 times square root of H. Ah, my idea doesn't come here. Number 5. Okay, I got it. Now I have an idea. I see. Because in this way, it's getting more complicated. I think this. I don't think it's a difficult question, but sometimes if don't use the right technique. Here we are going to use this one, A and B, right? 3 times X and 8 times X, right? And the highest common factor means that is among the factors, right? It is the biggest one that divides both of these numbers. And since A is equal to 3 times X and B is equal to 8 times X, so that means that what is the highest common factor? And highest common factor of A and B, that is equal to X. Is that right? So
Oh,
did you get it? Because here, what is the highest common factor? A is equal to 3x, right? B is equal to 8x. 3 and 8, they are relatively prime numbers. Their only common factor is 1. But here, what number actually divides A and B? That is x. X is dividing both,
oh,
right? So
yes.
x is the highest common factor. So just now we need to find x then. From here, uh, if it is so, so we know that A times B, that is equal to 384 times highest common factor. That's equal to X. What is A? A equals 3X. What is B? It is 8X. On the right hand side, 384 times X. So now they cancel each other. From here, what is X? 384 is divided by 24. That's equal to 16. You are right.
Mm.
I see. Now I can see that. At the beginning, I couldn't see this. Sometimes if idea doesn't come, we get stuck. And did you get it, Elmir?
Yes.
Yeah, that's. I think in this way it's much easier and clearer. Okay, good. That's it. Let's move on to the next question. Ayan, is everything okay? Okay, Elmir, read the question. Maybe she's tired today.
Thursdays of a certain month have the most number of dates, which are prime numbers. Which day of the week is the 13th of this month?
Thursdays of a certain month have the most number of dates. The most number of dates, which are prime, right? Which are prime numbers. So which day of the week is the 13th of this month? Did you understand the question?
Yes.
Okay, can you do it?
I think I know how to solve it.
Did you get it?
Yes, the answer is. Uh, I need 10 seconds. Sunday?
Sunday?
Yes.
Yeah, that's correct.
But the answer is not there.
None of the above, right?
Yeah.
Good. Because since we know that certain month, it can be any month. If the first day is Thursday, at the time, what days are Thursdays? 1, it is 8, 15, 22, 29. If the second day of the month is Thursday, at that time it is 2, 9, 16, 23, and 30. A third day, it is 10, 17, 24, 31. If it is 4, at the time we will have only 4 weeks. It was like 4,
And then it's the
11,
most too.
18, 25. So it's most, so we don't need this. But in the first one, what days are prime? It is only
Just
29.
29.
And the second one, it is 2 and 23. Third one, it is 3, 17, and 31. So that means that we are talking about this month then. That has the most number of days which are prime. That is 3 days they are prime. But since it says that it is 13th, right? So 10, it is Thursday. So 10, Thursday, Friday, Saturday, and Sunday. 13 will be Sunday.
I
So
did in exactly the same way.
good, very good. If you did in this way, I think that's only this way. I mean, doing this question. I don't think we can in different way. How can you do this? Because we have to just guess, right? I said the first day or second or
Writes
third
out
day.
all 7.
Huh?
Writes out all 7 of them. And then.
Okay. Okay. Let's continue. Then, if the 5-digit number A67A0 is divisible by 60, find the value of A. And divisible by 60 means
A is either 6 or 2, so we just need to check.
6 or 2. Why?
Oh,
It should be divisible by 4 and 15. And okay, the last digit is 0. We have no problem with divisible by 5 because if you write 4 and 3 and 5, they are relatively prime numbers, right? So to be divisible by 4, the last 2-digit number, it must be divisible by 4. It can be 20, 40, 60, 80. All of them are possible. But for 3, right, it is A plus 6 plus 7 plus A plus 0. That's equal to 2A plus 13. It should be divisible by 3. So that means that here we have, all right. Okay. So if it is 2, 17, No, if it is 4, 8, 21, yes. 6, 12, 25,
It's
no.
4.
8, so it is 4 only, right? When it is 4, it is divisible by 3. It's already divisible by 5 and also divisible by 4. So A must be 4. Good.
Tanya
So
is about to win a prize in a game. She's holding a standard six-sided dice, which would determine the prize she will get. She will get a $100 cash if she rolls 5 or 6. If she rolls an even number, then she will need to flip a coin. If the coin shows a head, she will get a book prize. If it shows a tail, she will get a chocolate package. If she rolls an odd number, she will get a gift. She will get a gift voucher. Which prize will she most likely get?
if she rolls an odd number, she will get a gift voucher. Which prize will
Gift
she most
voucher.
likely get?
Oh,
Odd number, 600. That means that what it
does
is.
5 is 5 and 6 count as odd and prime too? Is it possible to get two prizes?
What do you mean?
If she flips a 6, if she gets a 6, does she get $100 plus the coin flip?
Yes, because here it says rolls 5 or 6, right? So that means that he has chance 2 out of 6, which is equal to 1/3. And she rolls an odd number, right? She will get a gift voucher. And how many odd numbers we have? 3 out of 6. So
So
that
it's
is
50%.
1/2, which is 50%. And this one is 33.3%. And this one is 50%.
And the
And how about the
book
second one?
prize and chocolate package are each 25%.
And how about this? Say again, what did you say?
Book prize and chocolate package are 25% each.
If she rolls an even number, that is 2, 4, 6, then she will need a flip coin, right? So that means that here it is 2 heads or 4 head or 6 heads, right? And also that's what is the chance here? It is even number, then she will
It's
need to flip a
50%.
coin.
Yeah, so it's 25%. So the answer is gift voucher.
They give the watcher. Yeah, that is the highest probability. Okay. Find the smallest positive integer n for which 1 to 5. N is a multiple of 3600. Can you do this in 1 minute?
I will try to.
And it's quite easy question, but simple algebra, right?
It's um, um,
Aya Murad, are you here?
Yeah,
What are you doing?
solving.
Really? Why are
Yeah.
you so quiet?
What are we supposed to say?
Say like, oh, really? Wow. Oh, I was thinking different way. I had different idea. How about this one? I don't know. You can say anything, Ayan. I called your name, but you didn't say anything.
At that time, I wasn't here. I went to go get water.
Oh, I see.
the answer is 72.
So a multiple of 3600 means if you multiply 3600 by some k, we will get 1250, right? So k is a natural number. So from here, 1250 n over 3600. Now, if you simplify, and also by 5, it is 25. And by 5, 360, that is 72, right? So that means that since we are looking for the smallest value, this 25 and 72, they are relatively prime numbers. The only common factor they have is 1. So this n must be divisible by 72. So that is 72.
Mr. Casa,
Yes, I am.
I know another way.
Easier than this, shorter than this, faster than this.
Not sure if it's faster, but it's like the first thing that would come to mind, I guess. You can multiply each of them by 1250 and then divide the answer by 3600 to see if it's divisible. And if it is, then that means that it's the answer.
But you are not allowed to use a calculator. How do you multiply, Ayan? Multiplication takes time.
Why are we not allowed to use a calculator? That makes no sense.
Yeah, this is a mathematical contest, and let's say that is no calculator contest. Okay, because according to this, they prepare the questions. But if it is online, at the time questions are different because you are allowed to use a calculator. The questions will be different. But here for these questions, you are not allowed to use a calculator, and that's why actually, see here, numbers are just simple numbers. Because for simplifying, you don't have to know a lot of things, right? We are just simplifying this fraction. That is what they are expecting. Can a student think like this? Yes, I am.
You know, we will not write it online. We will go to some place and there we will write it, and we're only allowed to bring a pen.
How about eraser, ruler?
No, just a pen.
Are you sure?
They told me that.
Maybe they will provide. Usually, I don't know, everywhere. Here, when I organized Sasmo here, I arranged that piece of paper and even water, some candy, chocolate for students, and the eraser, ruler. I don't know how they are organizing. I have no idea. But usually, yeah, you are not allowed to use any telephone or calculator, but you're allowed to use a ruler, pen, pencil, and the eraser. Nothing else. But in
Well,
case,
you're
Ayan, you should take them
telling
with
me.
you. Okay, if they allow you, you will use. If they don't allow, then you just keep it outside.
I don't know. They said that we can't.
Then it's okay. Then no problem. Just pencil and your brain will be enough.
I don't think so.
You may not think so, but just hope so, Ayan. Sometimes hope, it makes impossible things possible. Even hope is very strong thing. Sometimes you think that it's not possible, but those things with your hope, it may become possible things. Okay, let's continue. Find the last two digits of 2018 to the power of 2018. Guys, you are allowed to use a calculator for this. For example, Ayan, let's say, can you answer this question?
No.
Okay, think. Okay, give it a try. Let me give you like 1.5 minutes, maybe 2 minutes, or maybe even we can do this together. In this kind of questions, what we have to do is we need to just write a few powers of 2018, and we try to see the pattern, and there must be a pattern because otherwise we cannot find this, right? It is a lot. Even I don't know, days will not be enough. So if you just calculate this, number one, I mean, for example, since we are talking about the last two digits, right? And 2018 to the power of something, the last two digits will be just the powers of 18 because 2000 plus 18. So now if I just write 18 to the power of 1, what is the last two digits? It is 18. 18 squared, the last two digits, It is 324. So the last two digits is 24. And how about 18 cubed? That means that I'm multiplying 18 by 24, right? So 18 times 24, 18 times 24, the last two digits, it is 32. And the next one, 18 to the power of 4. Now I'm multiplying 18 by 32. So 18 times 32, the last two digits, they are 76. Now 18 to the power of 5, still we don't have any pattern here. So 18 times 76, that is 68. Still no pattern. 18 to the power of 6, so that is 18 times 68. The last two digits, it is 24. Really? Okay, and one more, because now we have already 24. Now if I continue, it repeats, right? This one is 24. Next one will be 32 and
Yes, it will
76.
repeat.
If we just ignore this one, right? Here we have, what is it? This is a pattern. How many? It is 5. It's not 5, 4, right? Every 4 steps.
So the answer is B.
The answer is 2018. It's not divisible by 4, right? So 2016 is divisible by 4, right? 16. So it is 2.
Yes, it's
So
yeah,
it
2
must be
left.
24.
80. Yeah, 24.
So it is 24. Okay. What time is it? 41. Good. Ayan, we miss your voice. Can you read it?
Sure. The figure on the right is made of 5 cubes. The front and side views of the figure are shown below. What is the largest number of cubes in a figure with the following front and side views?
It's also an interesting question. The figure on the right is made up of 5 cubes. The front and side views of the figure are shown below. Okay, what is the largest number of cubes in a figure with the following front and side views? What do you think, Ayan? The largest number of cubes. For example, if you look at the cube from front side, right? And behind this, for example, behind the first row, what do you think? Maximum how many cubes there can be?
4.
1?
4.
4 more rows, right? Because we cannot say maximum, I can have 4 more. That means a 4 by
What?
4, 16. Right? Because you can just actually, to imagine this, you can fold your paper, right, 90 degrees, and you can just see the front view. In the first layer, we have 4, and also side view, we have 4. Behind them, I cannot see. So maximum, how many there can be? In the first layer, we can have 4 by 4. It is 16. And the second layer, again, one front, when you look at this, I can see 3. And also from side view, also I can have 3, right? And so that means that our cube is 4 by 4. So maximum how many behind this? We can have 3 by 3, that is 9. And also behind this, that is here by side view, that is 2 by 2, it is 4. And at the top only we have 1, so that is 1 by 1, that is 1. Altogether, how many? 30. Because it says largest, right? Maybe also, Ayan, what do you say, 4? That is a minimum, right? Minimum. Because we have only one actually row behind this, we don't have any. But here we are talking about the cube, right? That's why, actually, not 4, yeah, more than 4, but Okay, that's it. Let's move on to the next question. Let me read the question.
Royce and Sonny were running towards each other at a speed of 10 meters per second and 12 meters per second, respectively. They started running at the same time and met at point P after 10 minutes. The next day, they did the same thing, except that Royce increased his speed. As a result, they met 1,920 meters from point P. What's Royce's new speed in meters per second?
Ayan, did you understand the question? And of course, you have to read one more time. Here, they are running towards each other, right? The first case is Royce and Sonny. And they meet each other here. Let's say this M. But on the second day, Royce increased his speed, right? Of course, that means that he will actually run more distance. The second day, they meet each other here. And from the same, it is R and the S. So what is this distance? This one is M, right? So the distance is equal to 192 meters. And speed of the Royce, what is this? 10 and 12. So this one is 10 and this one is 12. And second day, we don't know. Let's say the second day, his speed is X, and the soil speed, it doesn't change. Still, it is 12. Okay. So what is Roy's new speed in meter per second? That is X. Any answer, Elmir, Aya, Murat?
No.
Ayan, did you understand the question? I think it is not so hard, right? Two people, they are running towards each other, and the first guy's speed is 10
I found the answer.
What is it?
It's 18.
18.
Yes.
Okay. So, good. Let's see. So the first day, right after 10 minutes. So actually the speed is meter per second. 10 minutes is equal to 600 seconds, right? So in the first day, distance covered by Royce, that is 10 times 600, that is 6,000 meters. And second one is 12 times 600, it is 72000 meters. So that means that the distance between them, right, that's equal to 13,200. 6,000, it was 7,200. On the next day, actually, they meet each other here, right? Let's say the meeting point, let me denote this T. So Royce, how many meters did he run on the second day? So that is 6,000 plus 1920. And how about Sony? It is 7,200 minus 1920, right? He covered this distance, right? And of course, they meet actually each other after a certain time, right? Times are the same. So that means that here, the second day, after 10 minutes, that's equal to distance run by Royce over the speed of Royce, that's equal to distance run by Sony, by her speed, right? Because they spend the same time, because they started running towards each other at the same time. So that's it. What is D1? 6,000 plus 1920, that's equal to 7920 over speed of Royce. We don't know new speed, it is X. The second guy, 7200, 7200 minus 1920, that's equal to 5280, and the speed of the second Gaston, that is 12, right? And that's it. Now from here we need to solve this equation. The 0 0, they cancel each other. What is X here? X equals 12 times 792 is divided by 528. So 12 times 792 and divided by 528, that's equal to 18. So the new speed of, what is it, Royce is 18. Okay. Princess Ayan, do you have any questions?
No, not really.
Did you get it? Did you understand every step?
Yes.
Good. All right, let's try to solve maybe one or two more questions. Okay. Now we have only 10 minutes, 9 minutes left for this question. Okay, let me just skip. We can discuss it on Friday at the beginning of the class, because now if you start solving this, it may take time, but it's not so hard question. Instead, let's solve 14, 15, and the 16. After that, we will finish it, okay? The rest we will discuss on Friday. Okay, 13. Okay, you try to solve this at home, because mathematical reasoning questions, really we have to practice, and you have to read, understand, make a table and solve it. It takes time. And that's why in Sasmo de Ayan, if you have such question, just leave it to the last minutes, okay? You just solve all easy questions, or the questions that takes less time. Still you have time, then try these kind of long questions. Okay, question 14. The sum of some consecutive positive integers is 2018. And find the largest of these integers. Because here it's not mentioned, okay, the sum of how many? 2 or 3 or 5 or 6 or 7 or 8, how many? So what do you think? Just tell me idea. Murad, Elmer, Ayan. How do we solve this question? Just tell me the idea. What do you think?
Maybe you can do x plus 1 plus x plus 2 equals 2018.
I found the answer already.
What is it?
It's C.
C?
Yes.
Okay, Elmer, I'll get back to you. Ayan, what do you mean? You're talking
1008
about
and
three numbers.
1010.
Oh, I think my idea is wrong because we don't know how many numbers they are.
Yeah, your idea actually close to my idea. That's why I was expecting the continuation of your statement sentence. Okay, good, because I'm now going to use your idea, Ayan, but a little bit in a slightly different way. Yes, Elmi, what did you say? Say again.
The answer is C, and the numbers are 1008 and 1010.
1008 and 1010?
Yes.
But 1008 and 1010, they are not consecutive integers.
Oh, wait.
Because consecutive means, right, the difference between them, if you just pick any two adjacent numbers, the difference must be 1, like 1 2 or 2 3, or 1 2 3 or 2 3 4 or 3 4 5, for example, like this.
How is it a positive number? How is it an even number if it's a
If
odd?
it is even number, at the time they should say consecutive even positive integers.
So the answer is E.
Answer is E. Why?
Because if it's A, B, C, or D, there are two numbers, and sum of two consecutive numbers is odd because it's odd plus even. So it's none of the above.
That's another approach. Yeah, you see, this kind of approach is also good for multiple choice questions. Because are you saying that, Elmir, because here two numbers, it's not possible, because here 2018, it is, what is it? Even number. So if you're talking about two integers, that is n and n plus 1. So the year sum is odd. So that means that now it must be at least 3. If it is 3,
3,
right,
5,
let's
or
say it is
7.
n plus 1 and n plus 2. That means that these numbers cannot be greater than, not 1000, even they cannot be greater than 700, right? So we don't have such
Yeah,
numbers.
around that.
So that's why
So
it
it's
must
E.
be answered. Okay. Another way is, suppose that, okay, two numbers, not possible. Three numbers, not possible. Let me check, how about four numbers? If it is four numbers, how do you write four numbers? Let's say the smallest one is n minus 1. Next one is n. It is n plus 1 and n plus 2. And if you just add them, n and n, I have 4n. Negative 1 plus 1, it is 0. So plus 2, that's equal to 2018. From here, what is n? 2016 is divided by n, that's equal to 504. So those numbers are 503, 504, 505, and 506. So which means that the largest of these numbers is 506. That is one way. Also, we have another general way, but this way is much, much simpler. Okay, first immediate test. The sum of two numbers, is it possible? No. Sum of three numbers, is it possible? No. Four numbers, yes, it works. And that's it. Okay, let's continue. One more question. Elmir, read the question.
How many two-digit positive integers can be expressed as the difference of two perfect square numbers? What
Okay,
does perfect square number mean?
we did a lot of examples to this, right? Like 1 squared, 2 squared, 3 squared, like 1, 2, I mean 1, 4, 9, 16. The square of a natural number is called a perfect square number. What are those numbers? They 1, right? 4, 9, 16, 25, 36, 49, 64, 81, 100, because these numbers are, I mean, in a perfect, in a sense that they are a square of a natural number. Okay?
So the word
So here,
perfect is not really important.
say again?
So the word perfect is not really important.
What?
Okay, never mind.
No, say again. Come on. You mean
So the word perfect is not really important then, right?
here?
Yes.
Why? Why?
Mm,
Are you saying that even if we just say here square numbers, we understand the same thing?
yeah.
Okay. Yeah, it is. But when you just say the perfect, you know, it is a natural number times natural number that produces this perfect square number.
I got confused because I never heard perfect square number.
Hmm. Okay, we have perfect square numbers, perfect square algebraic expression, and algebraic expression that we can write as a sum or difference of two things, where a plus b squared. We call this perfect algebraic expression. Anyway, so now if you don't know, now you know. Did you watch that movie? Now we can see me. It's a kind of magic tricks, right? So, guys, let's do this. That's the last question. If I give you time, we can do this, but it takes time. So here the question is, how many two-digit positive integers can be expressed as a difference of two perfect square numbers, as the difference of two perfect square numbers, as a difference of two perfect square numbers. Okay, Ayan, what do you think? How do you solve this question?
I'm not sure.
A squared minus B squared, that's equal to A minus B, A plus B, right? And that thing is a two-digit number. So what are those numbers? Like I can just write a few of them. Suppose that these are odd numbers, or not odd numbers. Let's say the difference is 1. So I can write 2, 1. It doesn't work. Uh, 4. Okay. I think we can write 2, 1. Okay. 3, 2. It doesn't work. 4, 3. 16 minus 9. Also no. 5. So here 5 squared minus 4 squared.
It doesn't work too.
It works. Why? 25 minus
Oh,
16.
yeah, yeah.
No, no, it's 9, right?
Yeah, it's 9. It's not a digit.
Okay, let's do like this. Let's say actually the second difference is 1. At the time, it's not 2, it's not 3, it is 4, right? I can write 4 squared minus 1 squared, 5 squared minus 1 squared, 6 squared minus 1 squared, and 7 squared minus 1 squared, and continue until what? Until 10 squared, right? 10 squared minus 1. Okay. All right. Now, how about if the second difference is 2? At the time here we have 4, right? 16. Yes, I can write 4 squared minus 2 squared, 5 squared minus 2 squared, and until if it is 11 is too much. Again, here we have 10 squared minus 2 squared. And how about the second difference, 3, for example? At the time, it's 16 minus 9. No, it should be 5. So here we have 5 squared minus 3 squared, 6 squared minus 3 squared, until, again, it is 9. So until 10 squared minus 3 squared. Okay. Then how about the second one is 4. 4 squared is 16. I cannot write here 5. It should be 6. 6 squared. So 16 until again 10 squared minus 4 squared. Okay. Yeah, let me stop here in this way. Okay, just count this. Elmir, now I don't have any shorter way. Do you think that we can find this in shorter way? Think, okay. Let's continue from here on Friday. I think that much is enough for today. Okay. Thank you very much for your attention, time, and patience. And on Friday, we will have the last class. Okay. And hopefully, we will finish this 2018. Maybe I will give you 2019 and 2020, and you will practice at weekend if you need it. Okay. If you think you don't have time, then I don't have to give you. Thank you very much. I will see you on Friday. Okay. Bye bye.
Goodbye.
Goodbye.
Bye bye. Thank you.